Start.
Assalamu alaikum everyone. First of all, I would like to thank our honorable course teacher MJ Raid Hassan Mojumdar sir for providing this opportunity to show this presentation. We have been selected as group number 2 and our group name is Electro Infinity. Thank you everyone for joining with us. I would like to request my fellow teammates to introduce themselves.
Assalamu alaikum. I am Muhammad Ashikujaman Rupom. My student ID is 221331535.
Assalamualaikum. I am Miraj Ahmed. My student ID 221331546.
Assalamu alaikum. I am Walid. My student ID is 221331545.
Assalamu alaikum. I'm Abdullah Al Nishad. My student ID is 221331536.
Assalamu alaikum. I'm Selim Reza Shagur. My student ID is 221331527.
Assalamu alaikum. I am Shimo Begum. My student ID 221331521.
Assalamu alaikum. I'm Yasir Arafat. My student ID is 221331525. I would like to host this presentation from here on behalf of my team. Today, we have designed L293D motor driver circuit in Proteus simulator and would like to explain the working principles and circuit details of this project. And we will also simulate the circuit on forward of this presentation. In this circuit, the motor driver circuit is a complete system for controlling DC motor speed and direction using L293D IC. Components of this circuit. We have used L293D IC, 2 DC motors, 4 diodes, 4 resistors, 2 LED for notifications, 12 voltage battery, and some analog sources. To explain this circuit, first we need to know what is motor driver IC. The motor driver IC is an integrated circuit chip used as a motor controlling device in autonomous robot and embedded circuit. L293D is the most commonly used motor driver IC. A motor driver is undoubtedly something that makes the motor move as per the given instruction or the inputs. It listens to the low voltage from the controller or processor and controls an actual motor which needs high input voltage. In simple words, a motor driver IC controls the direction of the motor based on the commands or instruction it receives from the controller. Many motor drivers follow different topology. In this circuit, we will focus on the popular edge bridge topology, which is used in the L293D motor driver IC. L293D motor driver IC has total 16 pins. Number 1, ENA, and number 2 is input pin 1. Number 3 is output pin 1, and number 4 and 5 is for ground pin. And number 6 is output 2, number 7 is input 2, and number 8 is VCC 2. In the other hand, in opposite direction, number 9 is ENB pin, number 10 is input number 3, number 11 is output 3, and number 13 and 12 is also ground. And number 14 is another output pin, and number 15 is input number 4, and number 16 is VCC 1. I would like to request my teammate Ashikujaman Rupom to simulate this circuit. As we can see in the circuit, when we have a high voltage in number 1 source, we have a motor that runs in reverse direction with the voltage of 10 volts. When we have high voltage in number 2 source, now it's running in opposite direction of the previous direction. It means reverse direction with again 10 volts. but it's minus 10 volts. In the other hand, in second motor, we can see it has also an high voltage and it's also running in forward direction with positive 10 volts. And when it goes zero in the first motor, it interchanging its directions. We have designed LED notification systems to understand which motor is running, as we can see here. Okay. In that case, we have all the inputs in high mode and no motors are running, but all LEDs are bleeping because we have an interlocking system in our switching, our source, that if every input goes on high mode, the motor won't drive, but the LED will notify that we have high mode in all sources, and we have to stop any one source high to low. Once again, we can see the directions of our motors, and both motors have positive 10 volts and both running in interchanging directions. So now, how this circuit is working and what is its principle? In order to have a complete control over DC motor, we have to control its speed and rotation direction. This can be achieved by combining these two techniques, PWM for controlling speed and H bridge for controlling rotation direction. A common technique for doing this is to use PWM pulse width modulation. Is a technique where average value of the input voltage is adjusted by the sending series of on and off pulses. The average voltage is proportional to the width of the pulse known as duty cycle. Is the higher duty cycle, the duty greater is the average voltage being applied to the DC motor in high speed, and the lower duty cycle is the less average voltage being applied to the DC motor, which is called low speed, and we have seen that already in our circuit simulation. How rotation direction works. H bridge for controlling rotation direction. The DC motor spinning direction can be controlled by changing its polarity of input voltages. A common technique for doing this is to use H bridge. An H bridge circuit contains four switches with the motor of center forming an H-like arrangement. Closing two particular switches at the same time reverses the polarity of the voltage applied to the motor. This causes the change in spinning direction of the motor, which we have already seen our simulation. This was our presentation for today. Thank you so much. Assalamu alaikum.